Welcome back, men. We're going to continue our lesson with section 8.3, special right triangles. Today we're going to be looking at 30, 60, 90 right triangles. So a 30, 60, 90 triangle is another special right triangle or right triangle with side lengths that share a special relationship. This time it involves an equilateral triangle. So remember here, if I'm looking at triangle ABC, it means each side AB, BC, and AC will have the same length. When you draw in the altitude, you get two congruent 30, 60, 90 triangles. So when I draw in segment BD, this segment BD bisects angle ABC. So remember, if it's equilateral, all these angles are 60. So that means this angle ABC is bisected. So now I have a 30, 60, and 90 right triangle. In the figure, you'll see that triangle ABD is congruent to triangle CBD. So if I set AB just equal to 2 times x, that means BC will be 2x and AC will be 2x. But because I drew in this altitude, it cuts segment AC in half. So that means segment AD is x and segment CD is x. We could find the length of the altitude here in this triangle using the Pythagorean theorem. So I zoomed in on the proof. This is the algebraic proof using the Pythagorean theorem. So we'll get going. This x squared refers to segment AD, if you wish. The A that I get right here, A squared, that's going to be the length of the altitude. And this 2x quantity squared, that's going to be the length of the hypotenuse. So if I go on and simplify 2x times 2x, I get 4x squared. I'm going to subtract the x squared from both sides, so I get that a squared is equal to 3x squared. I'm going to take the square root of both sides. So when I do that and simplify, I get that the length of the altitude is x times the square root of 3. But this x is the short leg. So you're going to hear me refer to it as A is going to be the long leg, and then x will be the short leg. So A, the long leg, is the short leg times the square root of 3. So looking at the theorem, this is theorem 8.9. In a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the short leg. The length of the longer leg is the short leg times the square root of 3. So the hypotenuse is going to be 2 times the short leg, and the longer leg is the short leg times the square root of 3. So everything is going to be in terms of the short leg. So it's important to note, remember our triangle inequality, which states that the smallest side lies opposite the shortest angle. So here, that's why if I look at my triangle, the short leg is always across or opposite the 30-degree angle. If I'm taking a look now, the long leg is always opposite the 60-degree angle, and we should have an understanding that the hypotenuse will always be opposite the 90-degree angle. Looking at example number 1, I see that I have a 60-degree angle, I've got a 90-degree angle, which means that the angle up here in the north is 30 degrees. So if I look, I'm given the side opposite 30 degrees, so that means the short leg S is equal to 5. And since I know that the short leg is equal to 5, I come over here and I see, oh, X is across from the 60-degree angle, so they want me to find the long leg. So the long leg is equal to the short leg times the square root of 3. So in this problem, the long leg is x, so x is equal to the short leg. The short leg is 5 times the square root of 3, so x is 5 square roots of 3. Looking at example number 2, I have a 30-degree angle, so that means that angle B is going to be my 60-degree angle. And I notice in this problem that they give me the side opposite of that 60-degree angle. So in this situation, the long leg is equal to the short leg times the square root of 3. But I was given the long leg. So 4 square roots of 3 is the long leg. That is equal to the short leg times the square root of 3. So all I have to do is find the length of the short leg here. It's real simple. You guys could see in order for these to be equal, that S has to be equal to 4. If you want to solve it algebraically, you would divide both sides by the square root of 3. And when I divide both sides by the square root of 3, I have 4 square roots of 3 divided by the square root of 3. Here, the square roots of 3 will undo one another. Really, they become 1. So I get that S is 4. So S equals 4. Both ways, you get the same answer. So now I'm asked to find the length of BC. So that is the hypotenuse. So the hypotenuse is equal to 2 times the length of the short leg. So in this situation, the hypotenuse is equal to 2 times 4. And that means that the hypotenuse is 8. Or BC length is 8. Example number 3 wants me to find both x and y. So I'm going to look. I got a 30, 60, 90 right triangle. So what side was given to me? So in this situation, I was given the length of the short side. So here, the short side is equal to 4 square roots of 3 divided by 3. So it's all right. We've seen these before in 45, 45, 90. We're just going to treat it the same way. I don't care what the short side is. We're just going to follow the formula. So x in this situation is going to be opposite the long side. So I'm going to write my formula. The long side is equal to s times the square root of 3. So in this situation, the long side is x. So x equals, and we saw already that the short side is 4 square roots of 3 divided by 3. And I have to multiply that answer by the square root of 3. So when I do that, I'm going to end up with x is equal to 4 times the square root of 9 divided by 3. And we're very good. We know that that's just x equals 4 times the square, 4 times 3 over 3. And simply the 3's become 1. Multiplying by 3, then I divide by 3. So x equals 4. Sticking with the problem, I need to find the value of y, and y is my hypotenuse. So the hypotenuse formula from our theorem 8.9 says that it is 2 times the short side. So in this situation, the hypotenuse is the y variable. So y is equal to 2 times, and again, I'm going to plug in what the short side is, 4 square roots of 3 divided by 3. Multiplying these, I have to multiply the numerator times the numerator, and then the denominator times the denominator. So again, numerators times the numerators, denominators times the denominators. Because we're multiplying here, y will equal 2 times 4 is 8 times the square root of 3. I can only multiply the numbers outside of the radical, and then 1 times 3 is 3. So y is 8 square roots of 3 divided by 3. Example number 4, I look and they give me this time the side that is opposite the hypotenuse. So here I know that the hypotenuse formula is equal to 2 times the short side. So in our situation, the hypotenuse is 48. So 48 is 2 times the short side. I divide both sides by 2 to get the short side. So the short side is 24. So I look at my picture and I have to identify which side is opposite the 30-degree angle. So this side right here that I have, that's going to be 24. Use the highlighter there by accident. So that's 24. And that means now if I want to find the length of the long side is equal to the short side times the square root of 3. So in our situation, the long side is equal to 24, and the short side times the square root of 3. So the side opposite the 60-degree angle right here, this side length will be 24 square roots of 3. Example number 5, I noticed that they give me the side length opposite the 30-degree angle, so I have the short side, so 21 is going to be my short side. So if I wanted to go on, that means the long side, L, is equal to S times the square root of 3, so it's just 21 square roots of 3. Again, using my formula for the hypotenuse, that is 2 times the length of the short side. So that is 2 times 21. 2 times 21 is 42. All right, example number 6 is asking me to find the value of x and y. I notice right here that they give me the length of the side that's opposite the 60-degree angle. So that's the length of the long side. So the long side is equal to S times the square root of 3. And I bet some of you guys could already see what's going to happen. We're probably going to need to go back to rationalizing the denominator. And it's not a probable, we're going to. So the long side in our problem is 18. So I need to find the length of the short side. So 18 is equal to S times the square root of 3. And in our problem, if you wanted to, x is the short side. So 18 equals x times the square root of 3. So carrying on, we saw these yesterday. I'm going to need to go on and divide both sides by the square root of 3. So I get that x equals 18 divided by the square root of 3. And yesterday I gave us a shortcut. So I see that I have radical 3 in the numerator. So all I need to do is bring that square root of 3 upstairs with the 18. And then in the denominator, I remove the radical 3 and I get 3. So now all I have to do is divide 18 by 3, and I get that x is equal to 6 square roots of 3. If you want to recall, rationalizing the denominator states that I need to multiply the numerator and denominator by the square root of 3. I'm just showing you algebraically. So this becomes 18 square roots of 3 divided by the square root of 9, which is 18 square roots of 3 over 3. And then we have to divide by 3, so we get 6 square roots of 3. Okay, solving for y, I know that the hypotenuse is equal to 2 times the length of the short side. In our problem, we found out that the short side is 6 square roots of 3. So y is the hypotenuse, 2 times the short side, which is 6 square roots of 3. So that means y is going to be equal to 12 square roots of 3. All right, last example, trying to find the length of D and F, and I look at my picture and I see that the long leg is given to me, so the long leg is S times the square root of 3. 5 is equal to S square roots of 3. I divide both sides by the square root of 3. So I get that S is equal to 5 square roots of 3 divided by 3 after I use my shortcut. So that means D equals 5 square roots of 3 divided by 3. If I wanted to find the hypotenuse is equal to 2 times the short side. So in our situation, the hypotenuse is equal to 2 times 5 square roots of 3, and I have to divide that by the square root of 3. But the hypotenuse is the variable f, so I replace that. So f is equal to 2 times 5 is 10 square roots of 3 divided by 3. That's it for today. I appreciate your time. Good luck with the homework.